About part one, I will introduce what are the null and alternative hypotheses that the Project 2 is testing. In Project 2, which investigates the relationship between total volatility and expected stock returns, the hypotheses are freedom to test the effectiveness of a volatility-based investment strategy. Specifically, the project evaluates whether there is a significant difference in returns between portfolios constructed based on the volatility of stocks. Here are the null and alternative hypotheses defined. Null hypothesis. There is no significant difference in returns between the low volatility and high volatility portfolios. This implies that investors cannot earn significant returns by investing a volatility-based long-short portfolio, suggesting that the market does not compensate investors for taking on higher volatility risks. Alternative hypothesis. There is a significant difference in returns between the low volatility and high volatility portfolios, indicating that investors can earn significant returns by investing in a volatility-based long-short portfolio. This would imply that the market does provide a premium for investments in higher volatility stocks, or conversely, that lower volatility stocks offer a better risk-adjusted return. These hypotheses are tested within the context of the project by analyzing the performance of quantile-based portfolios. The low volatility portfolio consists of stocks sorted into the lowest quantile based on their historical volatility, while the high volatility portfolio comprises stocks in the highest quantile. The long-short portfolio's performance, which involves taking a long position in the low volatility stocks and a short position in the high volatility stocks, serves as the empirical basis for testing this hypothesis. If the long-short portfolio exhibits significantly positive returns, the null hypothesis can be rejected in favor of the alternative hypothesis. Conversely, if the portfolio's returns are not significantly different from zero, the null hypothesis would be supported.
Okay, so next I will illustrate the methodology of the portfolio construction and how is it implemented in Project 2 code base. So the first step involves calculating the total volatility for each stock, defined as the standard deviation of daily returns. This calculation provides a measure of the risk associated with each stock and serve as a basis for subsequent sorting. In the Project 2 code base, this is achieved using this function, which is shown in this slide, which applied to the daily returns data stored in a data frame. The volatility for each stock is computed and appended as a new column in the data frame, facilitating easy access in later steps. And then following the volatility calculation, stocks are sorted into 3 quantiles based on their computed volatility. The first quantile includes stocks with the lowest volatility, and the third quantile includes those with the highest. The sorting process is handled using the pandas cut function, which categorizes the stocks into equally sized bins or quantiles based on their volatility. The categorization is crucial for the diversified portfolio construction that follows. And then for each volatility quantile, an equal weighted portfolio is constructed. In this setup, each stock within a quantile contributes equally to the portfolio's returns, regardless of its market capitalization or other characteristics. The code calculates the average returns of stocks within each quantile to represent the portfolio's performance. This step is vital to assess the impact of volatility on returns across different risk profiles. And then the methodology culminates in the construction of a long-short portfolio, which is designed to capitalize on the differential performance between the low and high volatility quantiles. The portfolio takes a long position in the low volatility quantile and a short position in the high volatility quantile. The return of the long-short portfolio is computed as the difference between the returns of the low volatility and high volatility portfolios. This strategy aims to exploit the presumed stability of low volatility stocks against the potential high returns but higher risk of high volatility stocks.
Okay, let me talk about the outputs of part 9. Firstly, we have variable called LS underlying bar, which represents the average volatility of a non-short portfolio. We also have a LST, which represents the T statistic of volatility. The T statistic value is equal to the mean of the sample divided by the sample standard deviation multiplied by the square root of the number of observations. Secondly, the average of non-short portfolio is 0.0073, which is a small number, and it suggests that risk is effectively controlled during the sample period of non-short portfolio. The last value is T statistic, which is equal to 1.3847. This value is less than 1.69 and greater than negative 1.69. This figures that there is no enough evidence to reject the null hypothesis, which means that there is no significant difference in fluctuations, as well no risk is detected.
So many factors can influence the research. First, a large sample size is essential as it strengthens the statistic power of our analysis and supports broader generalizations. Second, we must ensure the robustness of our methodology. Our method should comprehensively reflect financial market complexity, supporting the consistency and replication of our finding across different scenarios. Moreover, it's imperative to critical assess the assumption underlying our models. For the assumption can skew our conclusions, thus rigorous testing of this permission is necessary. Finally, we must consider real-world factors such as market conditions. These particular considerations significantly affect the viability and success of our strategies, linking theoretical research to practical applications.
About part 5, I want to talk about the further works based on Project 2. Based on the findings and the experiences from Project 2, several avenues can be exploited to deepen our understanding of volatility-based investment strategies and enhance the robustness of the current methodology. Here is a to-do list for further work. Examine other factors that could impact stock returns. Integrate financial ratios like a PE ratio, PB ratio, delta to equity, and others to study their interaction with volatility. Explore macroeconomic indicators to see how they influence the relationship between volatility and returns. Improve the method of creating volatility quantiles. Adjust the number of quantiles of the creation for sorting stocks into quantiles to capture more differences in volatility. Test the impact of dynamically adjusting quantiles based on evolving market conditions. Strengthen the statistical validity of the findings. Employ advanced statistical tests and models such as multivariate regression analysis to control for confounding variables. Use machine learning techniques to predict the performance of volatility-based portfolios. Conducting out-of-sample tests to evaluate the predictive power of the volatility-based strategy. That's all. Thank you.